Hello everyone. Now we'll look into another sorting algorithm called Heap Sort. Now this algorithm is one of the popular and efficient sorting algorithm with time complexity of big O of n log n. Now to understand working of this algorithm, let us consider we have an array consisting of unsorted elements 84, 92, 12, 17, 79, 60 and 20. Now we want to sort this array in an ascending order using heap sort algorithm. Now to do this, first we will create a heap from this number. Heap in the sense we will create a binary tree, a complete binary tree. So 84, root is 84, then 92, then we are having 12, then next you are having 17, 79, and then remaining two elements 60 and 20. So this is how we have created a heap. This is the first phase, okay, or first iteration. It's a recursive algorithm. Now once you are done with the, creating the heap, then you convert this heap to max heap. Max heap means again you will gonna to rearrange these numbers such that when you consider a particular node, and if that node is a parent node, then that parent must be greater than both left child as well as right child. Okay, so at the first instance we'll go from last level. As far as this tree is concerned, we are having two levels. This is level 1 and level 2. Okay, so at level 2, first 17 and 79, which one is greater? 79 is greater. So now we'll check 79 with its parent. Parent is 92. 92 is greater than 79, so no change. Then we go to next two. So there's nothing but 60 and 20. Greater one is 60. Okay, then we check compare 60 with the parent. Parent is what? 12. So 12, which is a parent, is less than the child. So we will swap or interchange these two. Okay, so the intermediate tree, what we get is this: 84, then 92. Over here now we'll have 60 and not 12. Okay, to the left of 60 is 12 and right is 20. We are not completed with the phase 1. Phase 1 is still going on. And then to the left of 92 is 17 and the other element is 79. Okay, now we'll focus on L1. This we did for L2. Now we're going for L1. At L1 we are having 92 and 60, and parent greater one is 92 and parent element is 84. 92 is greater than 84, so we will swap it. So after swapping, the root will be 84 and the child node will be not 84, root will be 92 and child node will be 84. Okay, and then again we'll compare L1 with L2. So we are having 84 and child of 84 are 17 and 79. 84 is greater than both the child. So the max heap after first pass will consist of, or that tree now consists of, at the root we are having 92, to the left we are having 84, to the right we are having 60, and then the remaining nodes 17, 79, 12 and 20. Now the array elements are 92, 84, 60, 17, 79, 12 and 20. Now this array is completely unsorted array. Now what we will do, we will remove the root. Root is what? The first element, that is 92, and this position will replace by the last element. Last element is what? 20. So 20 will come over here and 92 will be placed at position 20, and that position will say that is nothing but a sorted array. So this is sorted array, and the unsorted array now consists of 20, 84, 60, 17, 79 and 12. Okay, so this is the end of pass 1 of first pass. Now we'll again create the same, we'll again create the heap from the unsorted elements. So these are now your unsorted elements. Now from this unsorted elements again we'll create a heap. We'll convert that heap to max heap. After converting it to max heap, then we'll remove the last node, or not to the last node, we'll remove the root and add it to the sorted part. Okay, and we'll continue with this process. So now let's go with the second phase. Now in the second phase we'll create a heap. So this is my second phase. For heap, the root is 20, then we are having elements 84 and 60, then you are having 17, 79, and then only one element, that is 12. Okay, now first we'll check at level 1. Now one will go to level 2 because level 2 is already satisfied. Now level 1, elements are 84 and 60. Higher element is, or greater element is 84. Now we'll check 84 with the parent. Parent node is, or root node is 20, and 20 is less than 84, so we'll swap it. So if we swap it or interchange it, then at the root you will get 84, and here instead of 84 you will get 20. But now at level 1 the node has changed, so we'll compare that with level 2 also. And at level 2 we are having 17 and 79. 79 is greater than 20, so we will even interchange this. Okay, so at the end of the second pass, the heap whatever we will be getting, or the max heap, will now consist of, at the root you will have 84, to the left you will have 79, to the right 60, then remaining two elements 17, instead of your 79 we will have now 20, and then 12. So our max heap is ready. Now if you rewrite the array elements, now array elements consist of 84, 79, 60, 17, 20, and 12, and your sorted part was having only one element, that is 92. Now what we'll do, we'll remove root. Root is 84, and we'll place it at the last element, and the last element will add it at the root. Okay, so now your array becomes 12, 79, 60, 17, 20, and your sorted array will now have 84 and 92. So this is after second phase. Now we'll go with the third phase, or third pass. Let us create the heap. So 12, 79, 60, then you are having 17 and 20. At level 1 we are having two nodes, 79 and 60. Higher one is 79, so we'll check 79 with the root. Root is 12, so definitely this will exchange. So after exchanging or swapping, root will become 79 and here it will be 12. Now we'll check 12 with L2. At L2 higher number or maximum number is 20, so you will swap this because 12, the parent, is less than the child, that is 20. So at the end of pass 2 or third pass, the heap will consist of, at the root you will have 79, then you will have 20, to the right you are having 60, and then the last two elements, those are nothing but 17 and 12. So now again we'll create or rewrite this in the form of an array. So we'll get 17, 20, 60, 17, 12, and your sorted part of the array was having 84 and 92. Now you have got the maximum heap at the maximum element is 79, so swap with this, swap with the last element. So now your array or unsorted array will have first element as 12, followed by 20, then 60 and 17, and this 79 now gets added to your sorted part. So 79, 84 and 92. So that's the end of your third phase. Then we'll go with the fourth phase, fourth pass. We'll reconstruct the heap. Okay, so at the root you're going to have 12, to the left 20, to the right 60, and the last node, that is 17. So we'll check at level 1. At level 1 we are having two nodes or two values, 60 and 20. So higher one is 60. 60 is greater than 12. So we will swap it. We will swap over here. So after swapping, a max heap will be at the root. You are going to have 60, to the left 20, to the right 12, and over here what we have, the last element, that is 17. Now let us rewrite this array. So in the form of array, so 60, 20, 12, 17, and your sorted part consisting of 79, 84 and 92. So now we'll swap first and last element. So now your unsorted part will have 17, 20, 12, and now your sorted part will have one more element added over there, that was 60. So 60, 79, 84, 92. So this is the end of your fourth phase. Now we'll go with the fifth phase. Okay, and in the fifth phase or fifth pass, now root is 17, left child 20, right child 12. Okay, so at level 1 maximum element is 20, root is 17. 17 is less than 20, so we will swap it. So after swapping you will get the heap as, at the root will be 20, left 17, right 12. So let us rewrite in the form of an array. So 20, 17, 12, and your sorted array consisting of 60, 79, 84, 92. We'll swap first and last element. Okay, so now in unsorted you will have 12 and 17, and 20 will be added to your sorted part. So let me draw this proper, better. So 20, 60, 79, 84 and 92. Okay, now in unsorted part we are having only two elements, those are nothing but 12 and 17. So now we'll go with the sixth phase. Okay, or sixth pass. Root is 12 and left child is 17. Okay, then parent is 12, child is 17, so we'll swap it. So the max heap, root 17 and left child 12. We'll rearrange this. So 17, 12, then your sorted array consisting of 20, 60, 79, 84 and 92. Again we'll swap a root with the last element. There are only two elements. Okay, so what we'll have 12 and 17 will be added to your sorted list. So sorted list consisting of now 17, 20, 60, 79, 84 and 92. Finally the last phase, that is the seventh phase. There is one element, so that whatever the heap we are creating, that heap itself is a max heap, so we add this element directly to the array. So now your sorted array consists of 12, 17, 20, 60, 79, 84 and 92. So your array is completely sorted. So this how basically the heap sort algorithm works, and the time complexity of this algorithm is big O of n log n. As far as space is concerned, at every instant you are just removing the root element and exchanging its position with the last element, so you are not using any extra space or something else. Okay, so in that case we may require one extra variable to swap the values. So the space complexity of this algorithm is big O of 1. So that's it. In the case you like the video, then kindly hit like and subscribe. Thank you.